thing you should always do if there is a quadratic is factor it. Okay, so let's go ahead and factor our denominator. So we need two numbers that multiply to -2 and add to -1. Two numbers that multiply to -2 and add to -1. Make this a little thicker because you can't really see it. Okay. All right, multiply to -2 and -1. I heard -2 and 1. Who agrees that would be my numbers? Okay. So roots, this is not a special case. I talked about that in the video yesterday. A special case means that you have a number outside of the fraction. This is just a fraction. There isn't anything on the outside. So to find our roots, we just look at the numerator. When we set our numerator equal to 0, that would be x equals 0. And that means we have a root. So this is from the numerator. So that would just be x equals 0. There's nothing to add or subtract. So that means that 0, 0 is my x-intercept. I'm going to go ahead and plot that point. To find the y-intercept, you always substitute in 0 for x. That's how you do that. You're going to sub 0 for x. So that would be y equals 0 divided by 0 squared minus 0 minus 2. And what do you think you're going to get? Hopefully we're not typing that in our calculator. Because 0 divided by any number is going to give you what? 0. So that means our y-intercept is also 0, 0. Vertical asymptote, we have 2. We have 2. We're going to set both of those equal to 0. So I'm going to take the x minus 2, set that equal to 0, and the x plus 1 and set that equal to 0. So that means I have a vertical asymptote at 2 and also -1. I'm going to actually write that separate though. I'm not going to write it as. So we have one at x equals 2 and x equals -1. So if you have a highlighter, color pencil, let's go ahead and draw both of those in. So I'm going to draw in an asymptote at +2. And I'm also going to draw in one at -1. All right, is this top heavy, bottom heavy, or balanced? Bottom heavy. And who remembers when it's bottom heavy, what is the horizontal asymptote? 0. So I'm only going to draw that in on the edges. In behavior, that means you don't do anything in the middle. You don't do anything in the middle. It's only on the ends. Do we have a removable discontinuity? Does anything cancel out after I factor it? Nope. So that means that will be NA. And unfortunately for this one, we didn't really get a lot. So we got to do quite a few points. So let's go ahead. Let me get myself some space to the right. So let's go ahead and figure out what is this graph doing. All right, so first thing I would do is pick some numbers over here. So I'm going to go with -2, and then I'm going to pick something off further away. So let's do -2 and -8. So go ahead and pick up your calculators. Type that in. So when you type it in, you're going to have -2 divided by -2 squared minus -2 minus 2. I think it would be faster to not use a calculator, but you do what you're going to do. Then you're going to do it again with the -8. Just notice that I'm putting minus -8. So go ahead and see what you get for those two. Let me see. I don't know if I did this one in advance or not. Let's see here. That's different than what I had. So I need y'all to help me because I don't even have this one. Nah, I don't even have this one. That's weird. Okay, so what do we get for -2 when we type that in? What we get? -5? -1/2? Anybody else get -1/2? All right. I think that looks right. Because it would be 4 plus 2 minus 2, which would be 6, 4. Yep, -1/2. So -1/2. So that kind of helps me. So that tells me at the -2, first of all, I really need to know is, am I above or below? That's really what I'm trying to figure out on the ends. Okay, because they could both be on top. They could be both on the bottom. They could be diagonal. We don't know. So we just figured out that on this side, the graph is below. So we got -1/2. So that's going to go about here. And then -8, you probably got something even smaller. What did you got? What'd you get? 0.11 negative though. All right, so it's even smaller. So that's all I really need to know. So what's going to happen then? That means that it's below the asymptote. It's going to come in. And then when it hits that point, it has no other choice but to do what? Go down. Can't go up, because if it goes up, it's crossing the red line, and you can't cross the red line. All right, in the middle, let's go ahead and substitute in one number. Let's just see what it's doing at 1. So let's put in 1, because I want to see, is it going down or is it going up? So that's going to help us kind of figure out what it's doing. It normally looks like a cubic function. All right, so let's go ahead and do 1. So when we do 1, that would be Go ahead and substitute that in. So 1 minus 1 is 0, so that'd be negative 1/2. So I got negative 1/2. Make sure though, because I'm not really awake. I'm kind of using mental math. You got negative 1/2? All right, good. So that kind of helps us. We don't even really need to do anything else on that side because we can tell that it's doing the same thing. Oh, sorry. So this is here. So that means that this graph excuse me, y'all, sorry. This graph is going to start off high, come down, cross, cross, and then go down like this. So the asymptote is not in the middle. The vertical asymptote is not in the middle. Sorry, the horizontal asymptote does not go through the middle. That's what I meant. So here, notice that when I drew it in, I didn't draw it in the middle. I'm only drawing it on the edges. Like it's only here. But it doesn't go through the middle, okay? All right, so now let's go ahead and do the ends. The end, so let's plug in 3 and 8. Let's see if it's above or below. So we plug in 3. Let's see what we get. And we really don't even need to plug in 8, so we can take that off. We just need to plug in 3. Because I just need to know, is it positive or negative? That's really all I'm trying to see. Is it positive or negative? Is it above the horizontal asymptote? Is it below the horizontal asymptote? So just one number would be enough for us to figure that out. So we got 9. 9 minus 3 is 6. So 4. I think I get positive 3/4, but be sure. So we get positive. All right, good. So then that tells us that on this side, we're about here. So that means I'm going to come down close to that vertical wall, and then I'm going to turn and go straight out. And that would be my graph. So you can kind of see what this graph is looking like. So I'm gonna just trace it so you can kind of see. So it's on this side, it's like, so it's 3 pieces. Bottom heavy is the one that requires the most amount of work. Is bottom heavy. All right, any questions? Okay, so now let's do our end behavior. So the end behavior is the limit as x approaches plus and minus infinity, and I did that on all 3 of the examples yesterday. The limit as x approaches positive and negative infinity. So when I'm talking about end behavior, I'm talking about these arrows on the end. All right, I'm not talking about what's happening in the middle, because what's happening in the middle is not on the end. Can we agree with that? All right. What is my arrows doing on the end? Can we agree that they're going straight? They're not going up towards positive infinity. They're not going to go down towards negative infinity. They're both constant. And they're constant going towards what number? 0, which is my horizontal asymptote. And that would be your end behavior. Okay. So let's do the next one. Make sure that I didn't change it. I don't know why I didn't have that. It's kind of weird. Very weird. All right, let me see if I like the next one before we write it down. Yeah, we can do this one. Go ahead and copy it down. Get your paper all together with your stickers and stuff. Yeah, I think passes are on my desk. What's your first step? Factor. So that's what everybody should be doing. Should be a pen and that little turny thing. Oh, that's how you fill it out. That's okay. Today is the 14th. It's my baby brother's birthday. I know. It's crazy. Here we go. Okay, so let's factor it down. So this factors down to y equals, we got the difference of squares in the top. And then in the bottom, two numbers that multiply to be a positive 12 and add to negative 7, x minus 4 and x minus 3. So what factor can I remove? Has to be top and bottom, right? The x minus 3, we can take that away. So let's find this removable discontinuity. We're going to take the x minus 3, set that equal to 0. We get x equals 3. And now for everything else, as a matter of fact, I'm going to erase this one. For everything else, all of my questions, I'm using what I have left over. So the equation that I'm going to use to answer everything would be y equals x plus 3 over x minus 4. All right. So let's take that 3 and substitute it in. What do you get when you do 3 plus 3 over 3 minus 4? That's interesting. Sorry. I was just seeing if I did it. I did. Okay. Yeah, my paper is really, oh, okay, it is. All right, so we got, what did you all get, negative 6? Who got negative 6? All right, so we have 3 negative 6. So I'm going to go ahead and put an open circle at 3 negative 6. Okay. So we got that removable discontinuity. So roots, this is not a special case. Look at the top, which is x plus 3. Set that equal to 0. And we get negative 3, 0. Put a point at negative 3. My y-intercept, that would be y equals 0 plus 3 over 0 minus 4. which is going to be -3/4. So I'm going to put a point here. Vertical asymptote comes from your denominator. X minus 4 equals 0. So we have x equals 4. I'm going to go ahead and draw that in. X equals 4. Okay. Is this top heavy, bottom heavy, or balanced? Balanced. So because it's balanced, we just dividing our leading coefficients, which is 1 and 1. And 1 divided by 1 is 1. Let's draw that in. So if we look at it, we got all the points we need on the left side. So what I have is it comes in, it's really close to the horizontal, makes a slight turn, then it comes down towards the removable discontinuity. Pick up your pencil though, go over it, and then it goes straight down. So we need a couple numbers on the right side of my vertical asymptote, and I'm going to go with 5. And then I did 10 in my notes, but let's do 9. Let's do 9. So let's do 5 and 9. So that means we have 5 plus 3 over 5 minus 4. Then we have 9 plus 3 over 9 minus 4. Let's see what you get. And you can pick anything. When I'm choosing numbers, I always choose a number that's right next to the vertical asymptote because I know it's going to be a whole number. And then you could just pick any number down here, any one you want to. And I picked 9, you could do 8, you could do 10. So for 5 I got positive 8. Did you all get positive 8? All right, let's plot that point. And then 9, we got 12 divided by 5, which is like 2.4-ish. Is that what y'all got? 2.4?
Yes.
Okay. And you can really round that to 2. We're graphing by hand. It doesn't have to be perfect. You know, you can't really be accurate when you're graphing by hand. So 9, I'm just going to go up to around 2 and then draw it out. And that would be your graph. Now, what is the graph doing on the ends? If you haven't figured it out, if you didn't watch the video yesterday, it's always going towards the horizontal asymptote. In this example, my horizontal asymptote is at 1. So my end behavior is approaching 1. That's what I'm going to put in there. It approaches 1. And that would be it. Okay, let's do a slant, y'all. Let's go ahead and copy it down. Get all your notes together. And then after this, I will show you your test or your quiz. And I'm going to have you write down the next question for tomorrow. So tomorrow we'll have 2. So we'll go through homework, and then we'll do our 2, and then you all can start working on your study guides. Because our test is Friday. Sorry, y'all, I keep changing it. This is the one we're working on now. That's the one. So it's x squared plus x minus 6 over x minus 1. If something can be factored, you always do it. So this time we got to factor the top. Go ahead and factor it down. 2 numbers that multiply to give you negative 6, but add to a positive 1. So what would be my 2 numbers that multiply to give you a negative 6, but add to a positive 1? Negative 2 and positive 3. Good job. So this time when I'm finding my roots, I have 2. We're going to set both of these equal to 0 to find my roots. Both. So that means I have x minus 2 equals 0. Which is 2, 0. Then I also have x plus 3 equals 0, which is negative 3, 0. Let's go ahead and plot those 2 points down. Two, goodness, I keep 2 and negative 3. All right, y-intercept is always going to be the same. So when you're doing the y-intercept, I think it's easier to use the original one because you're only going to have to divide these constants at the end. So when you type it in your calculator, which we're not typing our calculator, but you have 0 squared plus 0 minus 6 over 0 minus 1. Well, that's just going to come down to negative 6 over negative 1, which is 6. So we have a y-intercept at 6. Okay. Vertical asymptote is going to come from your denominator. Take that x minus 1, set that equal to 0. If x minus 1 equals 0, then what does x equal? One, yep. So I'm going to draw that in. I'm going to use my highlighter feature. Well, no. Oh, yeah, I am. Okay, so I'm going to draw this in at x equals 1. Okay, so this one is top heavy, so we have to do synthetic division. This one is going to be a slant. So this is a slant because it's top heavy. All right, so I'm going to do that down to the side here. I'm going to go ahead and make my little L. Oh, I didn't write the 1 right here. X equals 1. Put that 1 there. Okay. So you always start by putting wherever your vertical asymptote is, that's the number that goes on the outside. So in this example, it's 1. So that 1 is going to go here. And then we're going to list the coefficients of the numerator, which are 1, 1, and -6. Let's go ahead and do that. I'm going to drop down to 1. What else do we do? Who remembers? Multiply the 1 by the 1 and put that here. And then what do we do? Add. That's all you need. We don't care about this last number. That last number doesn't mean anything to us. So you can stop after you do the second one. This first number is your slope, which is M. And this second number is my y-intercept, which is B. So the equation for my slant is y equals 1x plus 2. All right, so we have to graph that line. Now, because I'm on my iPad and I can't use a ruler, I put a lot of points, okay? You don't have to put that many points because you can just plot. So let's start off by plotting our y-intercept. So my y-intercept is at 2. So I'm gonna put a point there. I'm using highlighter to graph it. And then from here, I'm just going up 1 over 1, put a point. Up 1 over 1, put a point. Up 1 over 1, put a point. So that's what you're gonna do. Put down as many points as possible and then use your ID or some kind of feature to help you draw a straight line. And again, I'm using a lot of points because I can't use a ruler on my iPad. Yeah, down 1 over 1, down 2, because the slope is 1, right? So it doesn't matter. Like you can go, if your slope is 1, as long as your rise and run is the same number, it's going to give you a slope of 1. And I did up 2 over 2. You can do up 3 over 3. It doesn't matter. I just didn't want to confuse anybody with that, so that's why I didn't say anything. But I'm trying to just make sure that when I connect it, I'm going to go ahead and draw it in now, that it's in the right position. So you want to go ahead and draw that in. Oh, and we don't have any removable discontinuities, nothing cancels, so that would be NA. All right, we kind of have enough on the right side. We just need to put one number on the left because, again, I'm going to come in close to that vertical asymptote. I'm going to make a slight turn, and then I'm just going to roll down the hill because now my asymptote is a hill. It's just going to roll down. Let's just put one number over here somewhere. What number do you want to use? 6, 7, 8, 9, or 10? 6. All right, let's do 6. And again, you have an option of which form you want to use to substitute it in. I think I'll use the original. 6 squared plus 6 minus 6 over 6 minus 1. But you get the same answer. This is the same. You get the same thing if you did 6 minus 2 times 6 plus 3 over 6 minus 1. So you get the exact same answer. So it's really up to you. Whichever one you want to work with. Do you want to work with the factor form or do you want to work with the original form? Same thing, same answer. So the top one, that would be 4 times 9 because 6 times 2, 6 minus 2 is 4 and 6 plus 3 is 9. So that would be 36. But the same thing is going to happen here. 36 plus 6 minus 6 is also 36. So either way, you have a 36 at the top. And we're dividing it by 5. So 36 divided by 5 is something close to about 7.2-ish. So that means at 7, it should be under the slant though. So that's why it's so important that you make sure your slant is like in the right position. And then it's the same thing. It's just going to come down. It's going to hit this, hit that, and roll down the hill. And that would be your final answer. So we only have 4 minutes left. So I don't want to rush through showing your test. So I'll show you guys tomorrow on Wednesday. All right, before you pack up though, go ahead and copy this down for tomorrow. Oh, sorry, in behavior. In behavior. So now for the left side, we have the limit on the left. The limit as x approaches negative infinity of f of x. What is this left arrow doing over here? What is this arrow doing? It's not going straight, it's going down, right? So that means the limit would be negative infinity. Good. But on the right side, so I can't write it as one statement. I have to separate it. Whenever it's a slant, we have to separate it. As x approaches positive infinity, which would be this arrow, that arrow is doing what? Going up. So that would be positive infinity. All right. So real quick, either take a picture or copy down this next one, so that tomorrow we can just get started right out the gate. We only have 2 more left, so copy that down so that tomorrow we're ready to go. Ooh. Man.